Hello, this is the Applied Mathematical BRG. I am Zach Porter.
I'm Alex McDonald.
I'm Jinwoo Lee.
So in this presentation, we'll be covering design phase 3. We'll be going through project management, product architecture, our industrial design, system level and detail design for our CAD models, assembly times, cost sheets, and moving forward, testing and refinement.
This is our project management Gantt chart. As we have continued to progress along this project, we have been on task with all of our tasks and completing everything according to schedule. However, the schedule had to be flexible and changes had to be made, where especially in the addition of a new task, which was to create the instructions for the users to assemble and interact with the machine. This had to come after our presentation of our prototype, and it is currently in the process of being completed and has been completed. So this is our project design instruction matrix. As we added the instructions to the matrix, we were able to take the information from the concept testing from all 3 phases and also the results of the prototype to generate the information necessary to complete the task of creating the instructions.
So this is our product architecture figure. Each input, exit, transition, and station all have to accomplish a task in order for the BRG to have a successful completion. Each of these are grouped into chunks by color. Each chunks are they're kind of like grouped together essentially. And so out of all these chunks that we've decided that the easiest to replace for another concept or for additional learning would be the final chunk, and what it would be replaced with would be, instead of a slingshot, be a system of ramps. And the system of ramps, the user would choose the correct ramp at the correct height, and it would be able to provide some additional knowledge on the conservation of energy.
This is our project's industrial design, where we were able to test the quality of the user interface, the emotional appeal, the ability to maintain and repair products, appropriateness of resources, and product differentiation. The category where our product scored the best in performance was the product differentiation, as many of the other projects were based on physics concepts, but this project focused on math concepts that are not commonly shown in this type of way, such as probability and Fibonacci sequence. The part of our industrial design where the project scored the least was the ability to maintain and repair the product, because the setup of the machine itself required much accuracy and precision, which which would be difficult to achieve with the resources used to build the machine, where there were a lot of components that did not activate 100% of the time, so the maintenance would have to there would be a great amount of maintenance, and if any of these parts broke, it would be very difficult to replace.
So this is our system level design figure of our entire BRG system. Here's our drawing of the entire BRG, and here is the CAD model. As you can see, they're grouped up by color, and they're also grouped up by the assembly for each station. So this is station 1, this is station 2, and this is station 3. And a little bit of station 3 is in the back, but you can see most of it. So this is our system level design. As you can see, all the stations and the transitions are interacting well together. So this is our detail design. Each of these components was taken from each of the stations. This would be station 3, station 2, and station 1. This is the base for station 3, this is the handcrank for station 2, and this is the triangle for station 1. Each of them are dimensioned, and these were chosen for their drawings because of their importance in each station. Without any of these pieces, the entire BRG wouldn't be functional.
Alright, these are assembly timetables. When considering how we would be assembling the BRG, we decided that the 2 most common methods we'd be using would be manual insertion with a insecured part, and the manual handling that would involve us to rotate our parts. So the main ways that we would be assembling in this BRG are using hot glue, where we would put a part into a slot in another part, and so that can allow us for very low time frames, especially since a lot of our parts are a lot bigger. And we also learned when doing this to assemble it in a certain way to allow for the most efficient assembly time, as well as being very productive. We wanted to basically reduce assembly costs by reducing the time, and we found out the most efficient way to do that by assembling it to reduce the impeding views and impeding in reaches. This is our cost sheet. We developed this through all of the materials that we bought. We also included machine labor. So that specifically with this project had to do with the plexiglass. We had to laser cut it so we could effectively get the squares that we needed from it while also reducing the probability of it shattering. We also estimated the cost for assembly based on the assembly time for the parts that needed to be assembled. And we chose our tooling based on the amount that we would be using it and how long it would be able to last. So we managed to get some pretty cheap tools here that would last for a decently long time to a very long time for the hot glue gun versus the handsaw. We overall have a total cost of $54.48. So that is a little bit over what we originally estimated, which was $30, but we believe moving forward that we will be able to amend that. So moving forward, we want to capture more manufacturing processes. We want to use molding and we want to use 3D printing. We had a little bit of an issue with that during our project, but moving forward, we believe that we will be able to amend all those issues. We want to use those processes so that we can further develop our parts so that we can allow them to achieve the full functionality that we would like to get. Also, by using these processes, we will be able to reduce cost overall, since we will not be needing to use a bunch of parts just to acquire one functionality. We will be able to sum it all up with one part. We also would like to do stress testing, specifically for the unit circle and the Fibonacci spiral. We believe those are very important parts of this BRG, and we need to make sure that they can stay together throughout multiple uses. Also, we want to reduce the chance of failure, so we want to make sure that everything lines up and will work 100% of the time, or at least 95% of the time moving forward.